Okay, so last class period, remember we talked about this. So let's see if you remember what the difference is. Suppose we had 13 squared, oops, sorry, negative 13 squared like this versus this. All right. So the one that's on the left, what does that mean? Negative 13 in parentheses squared. Okay, so remember we talked about base and exponent. What's the exponent on the left? 2. What's being raised to the second power? So what's the base? Negative 13. All right, so negative 13 is being squared. So that means negative 13 times negative 13, which is what? I know the timetables only goes up to 12. 169. So positive times a positive is a, I'm sorry, negative times a negative is a positive. All right, now on the right, what's the exponent? 2. What's being raised to the second power? 13 only. 13 is the only thing being raised to the second power. So what's the base? 13. So that means 13 times 13. But whatever that is, I have what in front of it? A negative. So you just bring the negative down. So what's the answer here? Negative 169. Okay, so that's one of those that students sometimes mess up on. So one, the base is negative 13. The other, the base is only 13. Notice one has parentheses, the other does not. So you got to keep track of the differences between those two. Okay, now remember on the previous test, you had something like this. And I can't remember what the problem was, but I'll make one up. Suppose we had 2x minus y divided by 3xy. And you're told that x is 5, y is 2. So when you had this in the last test, what did that imply that you needed to do? So where we saw the variable x, what would you substitute? 5. Where we saw the variable y, you would substitute 2. Okay, so on the test number 2, and it was also on test number 1, so you basically said the numerator is going to be 2 times x, and what's x here? And whatever that is, you're subtracting y, and what's y? And then that's going to be divided by 3 times x, which is 5, times y, which is 2. So the numerator, if you use the order of operations, you're going to multiply before you subtract. So 2 times 5 is 10. 10 minus 2 is 8. The denominator, it's all multiplication, so you can multiply from left to right. That's the order of operations. So 3 times 5 is 15. 15 times 2 is 30. And then you reduced, if you could, and you could here because they're both divisible by 2. 8 divided by 2 is 4. 30 divided by 2 is 15. Okay? Now, in this section, or in this chapter, though, see how when I substituted numbers into the variables, those numbers were whole numbers? Remember, your whole numbers are 0, 1, 2, 3, 4, 5, 6, and so on. In particular, they're positive right here. So now we're going to look at some that are negative. So that's why we talked about these negative bases last class period. So this is going to be number 14, and that's on page 891. So again, the directions will say to evaluate. So it follows from something you've had before, which was on test 1 and test 2. So number 14, though, you want to find what x cubed is when x equals negative 2. That's what you want to find. All right, so just as before, where we see the variable x, what are you going to substitute? Negative. Now, what I would do in this case is, just like I did this, remember when I substituted whenever I substituted for x and y, I put those in parentheses. Okay, so I did the substitutions and I put those things in parentheses. Do the same thing here. So what is x? Okay, so I'm going to say -2 in parentheses, but what is that being raised to? Third power. And so what's -2 times itself 3 times? Now remember, you have access to a calculator, so you got to remember how to use your calculator. So remember, in your calculator, you would say, now you really need to know this without a calculator. So -2 times -2 is what? 4, and 4 times -2 is -8. All right, but on the calculator, you're going to say the base, put the base first. The base is -2, so -2. Oops, sorry, I forgot to put that in parentheses. Huh? Yeah, but okay, so notice they said it's the same. All right. Now, the parentheses is going to be important. Parentheses would be important. We talked about this if this exponent was what? Even. Okay? So you see, there's a difference between, say, -2 cubed versus -2 to the, let's say, 6th power, and you forget the parentheses. So -2 in parentheses means -2 times -2 times -2, right? Which is what? -8. But let's suppose you put this wrong into your calculator. Let's suppose on your calculator you did this instead. So you say -2 raised to the 3rd power. Now, the way I have it, what's being raised to the 3rd power? 2 only. We just talked about that, right? Right here. There's a difference between parentheses versus non-parentheses. So if I do this, then I'm telling the calculator to raise 2 to the 3rd power, and whatever that is, that's going to be a negative in front. So that's going to be -8, and they said it was the same thing. And it is. Only because the exponent is what? Odd. If you do this one, -2 times itself 6 times, -2 times -2 is 4. 4 times -2 is -8. -8 times -2 is 6. -8 times -2 is 16. 16 times a -2 is a -32. -32 times -2 is a +64. But if you put -2 in your calculator like this, without parentheses, according to what I'm telling the calculator to do, what am I telling the calculator to do? Raise only 2 to the 6th power. So if I press equal, notice I don't get 64. What do I get? -64. So you got to be careful. You got to be careful when you put parentheses here and you leave them off on your calculator. So an odd power is not going to matter, but an even power does. All right. So if you remember the best thing to do is when you substitute, put those in parentheses and use the parentheses in the calculator if you need to. If you need to use a calculator. All right, so that was number 14. Okay, then let's look at 18. So 18, you have this. All right, 18, you have this expression, -4x² y cubed. And you're told that x is 2. And y is -1. X is 2 and y is -2. So you want to evaluate this expression. So where we see the variable x, what are you going to substitute? 2. Where we see the variable y, you're going to substitute -1. All right, so what I would do is this. I would say -4 times, in parentheses, what do I put in place of x? Close the parentheses and raise that to what power? Second. Times y in parentheses. What's y? And that's being raised to the 3rd power. So that's the way I would write it first. Then I would go to each factor that's listed, and I would just rewrite it. So that's -4 times, what's 2 squared? 4 times, what's -1 cubed? -1. Because remember, -1 cubed means -1 times -1 times -1, right? And so a -1 times -1 is 1. 1 times this -1 is what kind of number? What number? -1. All right, so that's what you would do next. And then you would just multiply from left to right. What's a negative 4 times a positive 4? And what's a negative 16 times a negative 1? Positive 16. Okay? All right, so that's the steps you would show. Now, remember, you have access to calculators. So using your calculator to check, here's what you do. Notice, use a parentheses like we have it. So you would say this in your calculator. You would say negative 4, parentheses, 2 in parentheses, and that's being raised to what power? Second. And then parentheses, negative 1, close, and raised to what power? Third, equal, and you get 16. Okay? All right. And then finally, let's look at 20 with this. Number 20. You have 10 divided by 3y cubed, and you want to evaluate this expression when y is equal to negative 3. Y is equal to negative 3. So just like before, just like when test number 2, test number 1, where we see the variable y, what do you substitute? Negative 3. The only difference is that now you're substituting negative numbers instead of just positive numbers. So in test 1 and 2, when you did the substitutions, they were only positive numbers. Now you have negative numbers. So you're going to say 10 divided by 3 times, in parentheses, y. And what's y? And that's being raised to what power? The third, right? Yeah. So the numerator is 10. Now let's deal with the denominator. What's being raised to the third power?
3.
Nope. Negative 3. So what's negative 3 times itself? I'm asking this. What's negative 3 to the third power equal to? Yeah, so it's negative 3 times a negative 3 times a negative 3, right? Using the order of operations, what's a negative 3 times a negative 3? Positive 9. And what's 9 times a negative 3? Negative 27. So this part right here is negative 27. So this becomes 3 times a negative 27. So then I get 10 divided by, now if you don't know right off the bat what 3 times negative 27 is, use your calculator.
7,
Yeah, so you'd say 3 times negative 27 equals negative 81, right? Okay. All right. So that was 20. Okay? All right, now let's look at this. Okay, so suppose that, now you know that we have to talk about some terminology first. We know that 8 is equal to, let's say, 2 times 4, correct? You all agree? Okay. So notice that I rewrote 8 as a product of two numbers. Notice I said product because product means what operation? Multiplication. So I need for you to know that this 2 and this 4 are called factors. So they're called factors of 8. So a factor of 8 is what number? What's one of the numbers that's a factor of 8? 2. Because 2 times some integer or whole number, some other number, is 8. So 2 times some other number is 8. And also, if 2 is a factor of 8, that means that when you divide 2 into 8, you get what remainder? 0. You get a remainder of 0. I say remainder. What else is a factor of 8? 4. Because 4 times what number is 8? 2. And so a factor of 8 we know is 4, so that means that when I divide 4 into 8, I'm going to get what remainder? 0. Okay? All right, so now that's going to bring us to this. So remember the word factor. Okay, suppose we had this. Suppose I had 2 to the third power times 2 to the second power. Let's do 4. I don't want to use 2. So let's say 2 to the third power times 2 to the fourth power. Okay? Now, this exponent 3, what's the base here? 2. Okay, this exponent 4, what is its base? 2. What do you notice about the bases? They're the same. Okay. Now, we also know that 2 to the third means 2 times 2 times 2, correct? We also know, and remember, all this will be multiplied, so that's going to be times. We also know that 2 to the fourth means 2 times 2 times 2 times 2, correct? So notice that my operation here is only what operation? Multiplication. All right, so now on your calculator, I want you to use your calculator and tell me what 2 to the third times 2 to the fourth is. 2 to the third, so you're going to say 2 raised to the third times 2 raised to the fourth, and you get, what, 128? Okay, 128. All right. And then when you do this as well, when remember, all this is this, right? So if I were to multiply this out, I'd also get what? 128. Because this is this. All right, now, remember we said that the bases here were what? The same. Okay, now I want you to notice something. I want you to use your calculator and tell me what 2 to the 7th power is in your calculator. So 2 to the 7th is also what? 128.
So if they have the same base, you can just add the exponents?
Yeah. So notice that here, you see 2 to the third means 2 times 2 times 2? Mm-hmm. So if I did this, if I said 2 times 2 times 2 times 2, that really means 2 to what power? 4. If I said 2 times 2 times 2 times 2 times 2, that really means 2 to what power? 6? Or the 5th, right? 5th. If I said 2 times 2 times 2 times 2 times 2 times 2, that's 2 to what power? 6? Because how many factors of 2 did you see here? 6. What about how many factors of 2 do you see here? Notice I'm using the word factor. 7. So 2 to the third times 2 to the fourth is 2 times itself 7 times, which can be written as 2 to the 7th. All right? Now here's what I need you to remember is this. We're coming to a rule. When you multiply like bases, these are basically the same, correct? When you multiply like bases, what did I do to 3 and 4 to get the 7? You add them. Okay, so when you multiply like bases, add exponents. All right, so you're going to keep the base. So you keep the base. Notice I kept the base. The base was 2. So I kept the base, but just added the exponents. All right, so the rule is going to kind of look like this. So and this is called the product rule. Notice why it's called the product. Because what am I doing to these two, 2 to the third and 2 to the fourth? What am I doing to them? Multiply them. So it's called the product rule. So the product rule, and this is product rule for exponents. So all the rules we're about to talk about are for exponents. So the rules for exponents. Let's write as rules for exponents. All right, rules for exponents. The first one is called the product rule. Product rule. So the product rule says this. If you have a to the m power, now when I wrote a to the m, what is the base here? What's the base? A. What's the exponent? M. Times a to the n power. Again, what's the base here? A. What's the exponent? N. All right, so according to what we just discussed, what do you notice about the bases? They're the same, so it means I can rewrite this product as the base raised to a power. So what's my base? What's my new power? M, not mn, because mn means multiplication. What do I do to those exponents? I add them. So just say m plus n. M plus n. So m plus n is not the same as m times n. All right, so that's called the product rule. All right, so let's look at some problems with the product rule. So this is on page 891. And let's look at 22. So 22 is an easy one. We have y squared times y. Y squared times y. So if you look at that first factor of that product, which is y, it's being raised to what power? Second. If I look at the second factor of this product, which is y again, but it's being raised to what power? The first. If there's no exponent there, it's understood to be a 1. So remember, there's no exponent is understood to be a 1. All right. So according to the product rule then, I am multiplying like bases. Again, so what are the exponents? What's the first one? 2. What's the second one? So what's my answer? Y to the third. All right, so you add exponents. Keep the base, add the exponent. All right, 24, you have negative 5 to the 7th times negative 5 to the 6th. And all I want you to do there is just to write it as the base raised to the exponent. So don't use a calculator in this. That's not what they want you to do. On number 24, don't use your calculator. They want you to use the product rule. Are the bases the same?
Yes.
Can I use the product rule?
Yes.
Yes. So to use the product rule, I keep the base and do what to those exponents? Add them. All right. Now remember though, what's the base? Do I have to use parentheses? Yes. So that's negative 5, and what's 7 plus 6? 13. So that's the answer. All right.
So is it every time you have a negative number you use the parentheses?
No, I was. Well, we didn't have a negative number here, so I didn't need parentheses. Okay, so I would not put parentheses here. I'd leave it as 2 to the 7th. Here you have parentheses. You started off with parentheses, so keep the answer with parentheses.
Okay, got you. That's what I was about to ask.
Now, you got to be a little bit careful with what I just said, though. So in number 26, though, you have in parentheses, you have this expression, negative 2x cubed, times in this other parentheses, you have this other expression, negative 2x to the second power. Notice the difference between the parentheses here and the parentheses here is the parentheses here enclose the base. The parentheses here is just enclosing the expression. Okay? All right, now, a couple of things you got to remember. Let me just write this in review. If I have 4x cubed, this 4, which is a factor, because remember 4 times x cubed, so the 4 is a factor, x is a factor. But in particular, this 4 is a number, right? So remember when we solved equations, I said you divide by the coefficient? All right, so the 4 is called a coefficient. Remember in the test 1 and test 2, we talked about the word coefficient? So the 4 is a coefficient. So what I would do first here is, remember all this is what kind of operation? Multiplication. Notice when I read this, I'm reading this, even though it's in parentheses, these expressions are enclosed in parentheses. Notice when I read it, I'm reading it as negative 2 times x cubed times what? Negative 2 times what? X squared. So deal with the coefficients first. What's a negative 2 times a negative 2? Positive 4. And now the variables. I'm going to use a product rule with the variables because notice the variables are the same base, which is x. So what's x cubed? What's x cubed times x squared? X to the 5th. And so notice I didn't put the answer in parentheses. The parentheses here only enclose the expression. It didn't enclose a base. All right, so that's 26. All right, if you look at, let's say, number 30. All right, so in 30, you have negative 7, a cubed, b cubed. So you have this expression times this other expression, which is 7a to the 19th times b. So negative 7a cubed b cubed, that's my first expression, is being multiplied by that second expression, which is 7a to the 19th b. Deal with the coefficients first, but keep in mind that all this is multiplication. You don't see any other approach. You don't see an addition symbol. You don't see a division symbol. You don't see a subtraction symbol. It's all multiplication. So when you do the coefficients, what's the coefficient of that first expression? Okay, negative 7. What's the coefficient of the second expression?
7.
What do you get when you multiply them? Negative 49. So in the blank, you're going to have a negative 49. Now deal with the variables. This first factor that you see here, or the second factor that you see, is a. What's the exponent? 3. So there are 3 factors of a here. Do you have any other factors of a anywhere else? Right here. So that means that since I'm multiplying like bases, I can do what to those exponents? Add them. So it'll be a to what power? 22nd? Okay. And then b, multiply the b's together. Not b to the third, b to the fourth. B to the third times b to the first. 3 plus 1 is 4. Remember, there's no exponent there. It's understood to be a 1. This right here is understood to be a 1. It says b to the fourth. All right, so you got to be careful with the 1s, exponent 1. All right, so that's number 30. And then finally, let's look at 32. All right, in 32, you have, in the first expression, you have 12x to the fifth. The second expression, you have negative x to the sixth. In the third expression, you have x to the fourth. So you have 3 expressions being multiplied together. Let's talk about the coefficients first. In the first parentheses, what's the coefficient? 12. The second parentheses, what's the coefficient? Negative 1. The third parentheses, what's the coefficient? 1. So it's 12 times a negative 1. I'm saying 12 times a negative 1 times a positive 1. Not 12. Negative 12. Negative 12. Yes. Yeah. So in the blank for the answer, you're going to have a negative 12. All right, now take care of the x's. X to the fifth times x to the sixth times x to the fourth.
15.
X to the 15. Okay. So there's your answer. So the answer is negative 12, x to the 15. All right, so that's a product rule. That's called the product rule. Okay, so then, though, on my math lab, and I didn't put any on the worksheets like this, but on my math lab, they're going to have something like 34. So in 34, they had this diagram. Looks like this. And you're told this. You're told that this is a parallelogram. And remember, parallelograms, opposite sides have the same length. That's the main property of that's the definition of a parallelogram. Opposite sides are well, parallel. Opposite sides are parallel. One of the properties, though, is opposite sides have the same length. You're told this parallel below has base. Oh, and also remember this from high school geometry. So, you see this dotted line? Let's see if any of you remember this from high school geometry. What does that dotted line represent about this parallelogram? Do you remember? No. Height. That's the height of the parallelogram. Notice that this height, which is also called an altitude. So this height, the altitude, always forms a right angle to the opposite side. So notice that this right here means a right angle. So this side then right here is called the base. This is called the base. So this is your height, this is a base. So here's what the problem says. The parallelogram below has base length 9y cubed. So if this is a base, then this right here is 9y cubed meters. So the length is in meters. Then it says is the height is 2y to the 10th. So this right here is 2y to the 10th meters. So this represents the base, this represents the height. And the question is find the area. Find the area of this parallelogram. All right. So now remember, if this was a rectangle, if this was a rectangle, what's the formula for the area of a rectangle? Length times width, or width times length, right? So length, width, or width, length, it doesn't matter. But the area of a rectangle would be length times width. Notice that a rectangle, they form what kind of angles here? Right angles. All these are right angles. So remember we just talked about this dotted line that forms a right angle. This dotted line is called a what? The height or the altitude. Let's particularly use the height because the problem uses the word height. So doesn't this form a right angle here? So we can consider this right here the height of this rectangle. And this would be the what? The base. And so remember we said base and height. So the area of a rectangle, I can even use the words base and height instead. So the area of a rectangle, instead of just saying length times width, I could say base times what? Height. Same thing is true for a parallelogram. It's the base times a what? Height. So the area of a parallelogram is base times the height. Base times the height. And so all you do is multiply the base and the height together. So what's the base here? 9y cubed. What's the height? 2y to the 10th. So what's the answer? 18y to the 13th. Okay, 18y to the 13th. Now, the units. Let's talk about the units because in my math lab they may ask you about the units or they may already have the units there. If it's multiple choice, they're probably going to have the correct units and the wrong units. So when we talked about finding the area of this table, let's say I want to find the area of this table. And let's say this table is, I'm making the numbers easy. Let's say 10 inches, the length is 10 inches, and the width of this table is 3 inches. What's the area of this table? 30 what? Inches? Nope. Your 30 is correct. Your units are incorrect. Square inches. 30 square inches. That's the area. So the area is 30 square inches. Or remember, you can also write it as 30 inches squared like that. All right. Now remember, it's kind of easy to remember where there are two ways you can remember about why is it square inches and not just inches. Well, remember, you're multiplying, right? So inches times inches is inches what? Squared. Okay? The other idea is this. When you are finding the area of a rectangle or any figure, it doesn't have to be a rectangle, it could be an irregular solid, we're saying that this area is 30 square inches, right? So that means that I'm going to have 30 little squares in here, 30 little squares, there'll be 30 of them, where this is 1 inch and this is what? 1 inch. 1 inch, 1 inch, 1 inch, 1 inch, 1 inch, 1 inch. So it'll be 30 of those. So that's where that 30 comes in. So 30 square inches. So each of those is a 1 square inch. 1 square inch. That's where that comes from. So on my math lab, when you put the expression 18y to the 13th power, you really need to put the units. So what are the units? This is in meters, so what are the units? Meters square or square meters. Or you could say 18y to the 13th meters to the second power, like that. All right. So in my math lab, they do have some geometry figures, some geometric figures. Now notice that the formula was not given to you. So if in my math lab they give you, let's say, a triangle, and they ask you to find the area of a triangle, and you don't remember it, just Google the formula for area of a triangle. Google it. But what's the formula for the area of a triangle? Do you remember? 1/2 base times height. 1/2 base times height. So just Google it on my math lab. Same thing for circle. You probably don't remember the area of a circle. The area of a circle is, do any of you remember? Nope. It's just pi r squared. Remember the number pi? The irrational number pi? Pi r squared. Where r means what word? Radius. All right, so that was product rule. All right, now let's look at this. Okay, now, suppose I had this. Suppose I had 2 to the third power raised to the second power. 2 to the third power raised to the second power, okay? All right, so look at that outer exponent. What's that outer exponent? 2. What is being raised to the second power? 2 to the third. That's what you have to say, 2 to the third. So we consider 2 to the third the base. So the base for this exponent 2 is 2 to the third. Now remember, what does that exponent tell you to do about this base? Multiplied by itself twice. So this means 2 to the third times 2 to the third, right? 2 to the third times 2 to the third. Well, according to what we just learned, I can now use the product rule. What's 2 to the third times 2 to the third? 2 to the 6. That's 2 to the 6. When you multiply like bases, add exponents. All right, but notice what I went through to get that 2 to 6 from what we just did. So I looked at the outer exponent. Then what was inside the parentheses is going to be considered the base. So now rewrite the base as a product, the exponent number of times, and then just use a product rule. But what if I had this? What if I had 2 to the 5th power raised to the 100th power? Well, again, what's that outer exponent? 100, right? So that means that my base is what? 2 to the 5th. So according to what we know, this expression right here indicates that 2 to the 5th is being multiplied by itself how many times? 100. 100 times, right? Right. So here's the idea. Let's go back to the one we just did. My answer, the exponent is what? 6. But what I want you to notice is that I can get 6 not by doing this expansion right here, not by doing this expansion, but just using the fact that, remember, multiplication 3 times 3, I'm sorry, yeah, so 3 plus 3 is the same as 2 times 3, right? Okay, 3 plus 3, because remember, when you multiply base, we do those exponents, you add them. So isn't 3 plus 3 the same as, how many factors of 3 do you see? How many numbers 3 do you see? 2. And isn't that what this is? So when you have a power raised to a power raised to a power, what do you do with those exponents? Multiply. So 3 times 2 is 6. Same thing here then. 5 plus 5 plus 5 plus 5, how many 5s are there? 100. So you're saying 5 plus 5 100 times. Well, that's the same thing as saying 5 times what? 100. Well, isn't that what this is right here? So when you have a power raised to a power, what do you do those exponents? What do you do those powers? You multiply them. So a power to a power, you're going to multiply. That's called the power rule. So rule number 2 is the power rule. The power rule.
Down to know the answer now. What that answer is.
Oh, so this right here will be 2 to the, oh no, you're not going to, no, they would just tell you leave it as 2 to the 500 power. Yeah. All right, so the power rule, then let's say we had this. Let's say we had a to the m power, and all that's being raised to the n power. So notice I have a power raised to a power, right? So what do I do to those exponents? So that's going to be a to what power? M, N, or N, M, it doesn't matter, but let's put it in alphabetical order. So M times N. All right, so remember the first rule, you added the exponents. In this rule, you do what to those exponents? Multiply. All right, so now let's look at some problems dealing with this. All right, suppose we had 36, and this is on page 892. So you have y to the 7th raised to the 5th. You know the answer now. What's the answer? Y to the 35th. That's the answer. All right. Okay, so let's look at this example first. All right, this example. Suppose I had this. Suppose I had x squared y cubed raised to the 4th power. Oops, I'm sorry. I didn't want to do this yet. Sorry, that's going to be later. Don't do this just yet. That's going to be the next rule. Next rule. Don't do this one. All right. So let's look at 38. All right, 38, you have a, b to the 6th. Now, to be honest with you, that could be the next rule as well, but they do have it in this particular part. They do have it here. Okay. All right, so let me go back and mention the power rule is this, right? Y'all agree? Okay. With this, don't worry about this. I'm not reading the directions very well. So in this book, they kind of mixed them up, so I didn't mean to do this. The book mixes it up. So let's write this example. Suppose we had y to the 8th raised to the 4th power. What's the answer? Y to the 32nd. And that's all the power rule was. Okay? That's all the power rule was. Okay? Power raised to power, you do what? Multiply. All right. Now, those two things I kept crossing out, it still involves a power rule, but it's also called something else. So that's what I want to talk about. All right. So listen carefully. What we're about to do. And then we're going to discuss the name of that particular rule. So the section, if you look at the problems that deal with this, they've mixed the two rules together. All right, so the first one's a power rule. That was the easy one. And then let's talk about how to get this one, these two. Okay, so suppose I had this. Suppose I had x squared y to the 3rd raised to the 2nd power. Okay? X squared y to the 3rd raised to the 2nd power. All right, now let's do the same discussion that we did when we did 2 to the 5th and all that. So let's talk about what this means. So what's the outer exponent? 2. What's being raised to that 2nd power? X squared y cubed. So that's going to be my base. So I'm going to consider this the base from our discussion. So that means that I'm going to take this base right here and I'm going to multiply it by itself how many times? 2 times. And since I wrote it like this, then I can use the product rule. What's x squared times x squared? Now notice what I said. I said x squared times what? X squared, which is what? X to the fourth. What's y cubed? Times y cubed. Not y to the ninth, y to the sixth.
We add.
You add exponents. So that will be the answer. So the answer would be x to the fourth, y to the sixth. Okay? But that's the long way to do this, because suppose this outer exponent was 200. Then again, you don't want to do that just like we did with that 2 to the 5th to the 500. Okay, you don't want to do that. All right, suppose this is 200. You would have to say x squared y cubed times itself 200 times. So rather than doing that, you want to look at it this way. If I cover x squared, what rule can I use here? The power rule. Y cubed squared is just what? Y to the 6th. If I cover this factor right here, what can I use here? The power rule as well. 2 times 2 is what? 4. Notice though, inside the parentheses, you see a product, right? And this is called a what? Exponent, or what other word do we use? Power. So this is called, this process that we just did here is called the power of a product. So the third rule is called the power of a product rule. All right. Now, here's how we're going to discuss the power of a product rule based on the notation that you're going to see. Let's go back to this problem right here that we just did. So remember I said this. I said if I cover the x squared, then this looks like what rule? The power rule. So mainly it means this. It means y cubed raised to what power? Second. If I cover y cubed, then that means I'm taking x squared raising what power? Second. So see this notation right here where I use parentheses? You're going to see that here. All right. So here's the power product. Power product is where you have products, and it could be more than two factors. But we're going to use two factors for the notation. So let's suppose I had a to the, well, let's just say a times b. A times b. Okay? What's my product here?
AB.
AB. What's that first factor you see in this product? A. What's the second factor you see? B. And let's say whatever that is being raised to the m power. M power. Then based on what we just did here, that says I take the first factor, A, and I raise it to what power? M. And I take the second factor, which is what? B, and I raise it to what power? M. Okay?
And you add them together, right? The AM plus the
No. That's not where you get why you want to add them. Remember, the only time we talked about adding was when you multiply like bases, you add exponents. The bases here are the same or different? They're different. So that's your answer. You leave it like that. Just like over here, x squared y cubed squared is just what? X to the 4 times y to the 6. That's the answer. All right, but that comes from this right here when we just did x squared squared and then y cubed squared. That's just the power of a product rule. That's what was used here. So now let's look at this one. All right, so this is going to be number it's going to be 42. So in 42, you have a to the 4th b all raised to the 7th. A to the 4th b all raised to 7th. Now don't do this. Don't say a to the 4 times b, a to the 4 times b, a to the 4 times b 7 times. Don't do that. What rule are you using here? Power of a product. And the power of a product also involves the power rule. The power rule. So basically the power of a product says this. Now if you need to, you don't have to write the second step. You don't have to write this step. This is optional. But basically what you're doing is you're taking a to the 4th and you're raising it to what power? 7. And you're taking b and raising what power? 7. So you take each factor that's inside the parentheses and you raise it to that 7th power. Now, you didn't have to do that because you're dealing with variables. So that's kind of easy to deal with. So what's a to the 4th to the 7th?
28.
A to the 28th. And then remember, that's b to what power? The first.
Yeah.
All raised to what power? So what's the answer? B to the 7th. So the answer is a to the 28th, b to the 7th. All right. Now let's look at number 40. Number 40. All right, 40, you have this instead. You have 4 x to the 6 squared. 4 x to the 6 squared. Now, you see you have a coefficient that's other than 1. See, the coefficient here was 1 right here. That was a 1.
We do the entire.
Yeah, so let's kind of, now, if a student messes up with this kind of problem, they're going to mess up with the coefficients. So what you may want to do is actually write in that second step. So you may want to say 4 is being raised to what power? Second. X to the 6 is being raised to what power? Second. And then come up with the answer. What's 4 to the second? Don't say 8.
I got 16.
16, because 4 to the second means 4 times 4. So that's 16. What is x to the 6 squared?
Extra.
X to the 12. So there's your answer. So that's 40. Let's look at 44. All right, so 44, you have negative 3 x to the 7th y z squared, all raised to the 3rd power. Now, many of you don't have to put in that second step. Many of you can go from this to the answer. But just remember that every factor that's in that parentheses has to be raised to what power? The 3rd. So if you want to skip that second step, just be careful with the coefficient. The coefficient in your mind is saying, what's the coefficient here? Negative 3. Negative 3 has to be raised to what power? The 3rd. So I would, with the coefficients, I would be very careful. So what is negative 3 to the 3rd power?
Negative 27.
Negative 27. So then you get negative 27. And now do x to the 7th. It's being raised to what power? The 3rd. Now remember the power rule. So when you multiply, when you have a power raised to power, what do those powers? You multiply them. So it'll be x to what power?
21 powers.
All right. Now let's do the y. Y right here has what exponent? 1. A power raised to power. You do what to those powers? So it'll be y to what power? 3rd. And then finally z to what power? 6. Okay? So that's all you do there.
The whole last part. It's a long one.
All right. Let's look at 46. 46. So in 46, you have a fraction, q, that's a q, divided by t, and all that's being raised to the 11th power.
So Q over T.
Yeah. So you just do it just like you did that's a q divided by t. Yeah, q divided by t.
It still be Q divided by T to the 11th power, correct?
Hmm?
Wouldn't it still be Q to T to the 11th power?
Wouldn't it be
Like Q to.
All right. So remember we talked about the power product, right? All right. So when you divide, what word do we use for division? Huh? What? Quotient. Quotient. We'll use the word quotient. So the 4th rule is called the power of a quotient. Power of a quotient. So if you can do the power of a product, then you can do the power of a quotient. So the power of a quotient just says this. If I have A divided by B raised to the m power, that's a quotient, fraction, A divided by B, the word division means quotient. So A divided by B, so I have this quotient. all I do is take the numerator, raise to that power, and then take the denominator, raise it to that power. All right, it kind of makes sense because watch. It kind of makes sense because let's suppose I had this. Suppose I had 2 to the third cubed. Okay? 2 to the third cubed. Y'all agree? Well, 2 to the third means 2 to the third times itself how many times? 3. So make sure you understand. And then 2 times 2 times 2 is 2 to what power? Third. 3 times 3 times 3 is 3 to what power? Third. So basically, according to what we just did, this says that I take the numerator, raise it to what power? The outer exponent. And I take the denominator and raise it to that outer exponent. So using this simple example, then I can come here and say that when I have a fraction raised to the n power, I can use a quotient rule. Quotient rule says I take the numerator and raise it to that power. And then do what else, though? Take the denominator and raise it to that same power. Okay? Now, using that power of a quotient rule, then what do you think the answer for this would be?
2 to the 11th power over 3 to the 11th.
Where are you getting 27 from?
Oh, we went to choose on the other problem.
Oh, I'm sorry. Okay. All right. Oh, you're talking about, yeah, that would be 8 divided by 27. Yeah. All right, but q to the 11 divided by t to the 11, right? All right. So knowing the quotient rule now, the power of a quotient, notice I said power of a quotient. Power of a quotient. Let's look at this one. So this is number 48. Don't make it difficult. So we have this quotient. The numerator is xy. The denominator is 7. And this fraction is being raised to the second power. Now, if you need to, do it in steps if you have to. Okay, so based on what we said, the power of a quotient, this says I take the numerator. Remember, I'm writing what we're saying. I take the numerator, and what is my numerator? xy. It's being raised to a power. Second. I take the denominator, which is what? It's also being raised to the what? Second. And now that's not the answer because you need to get rid of that parentheses and rewrite 7 squared. But notice the numerator, based on what we talked about a while ago, the power of a product, that's just what? X squared, y squared. The denominator was 7 squared. There's your answer. That's what you would say. You would say that's going to be x squared, y squared divided by 49. So if you have to write in that middle step, you write in the middle step. Yes.
So the middle step wouldn't equal the same step. Like if you wanted, you couldn't leave it like xy to the square.
No,
to break it
you
down.
have to write it like this.
Okay.
Yeah. So that is kind of your mental thought about it, and then this is your answer. You can't leave the parentheses in there. Do not leave parentheses in your answer. So notice, if you go back to all the ones we've done, there were no parentheses when we did these rules, except for when we had that -5 to the third times -5 to the fifth. We wrote as -5.
I guess when I was asking, like, we couldn't leave an xy to the square.
No,
without the-
that has parentheses in it.
No, if you take the parentheses off of that, just the xy to the second power.
You're talking
Like,
about
rewrite it, yeah.
this?
Yeah, we couldn't leave it
That
like that.
okay? So she says, can I write it like this? Well, x is being raised to what power? Yeah, that'll be wrong.
Oh, okay.
X is raised to what
Because it's
power?
not 1.
1. It needs to be raised to what power? The second. Okay, so no, that's incorrect.
Find out.
Okay, so now let's look at this. All right, suppose we had this. Suppose we had 2 to the 4th power divided by 2 to the 3rd power. 2 to the 4th power divided by 2 to the 3rd power. All right, so let's just use a calculator for right now. What's 2 to the 4th if you need to use your calculator? 16. 2 to the 4th is 16. What is 2 to the 3rd? And what's that reduced? 2. So 16 divided by 8 is 2. Okay? All right. Now, And that's really 2 to what power? To the first. Okay. So remember the product rule. So if I had this time you multiply. When you multiply like bases, what did I do to those exponents? You add them. Right? Here, notice this base right here is what? 2. This base right here is 2. So I am dividing like bases. Here I'm doing what? Multiplying like bases. Multiply like bases. What do those exponents? Add. Here I'm dividing like bases. And I ended up getting an answer of 2 to what power? The first. So what can I do to the 4 and the 3 to get a 1? Subtract them. So we divide like bases. Subtract exponents. When you multiply like bases, add exponents. When you divide like bases, subtract exponents.
I have a question. You're saying when we multiply the 2 to the 4th times 2 to the 3rd,
Yes?
you're multiplying 2 and 2 as 2.
No.
That's why I was kind of
They
confused.
like terms, so they gonna
So
No,
you're
you
gonna
keep
leave
the
them same
base.
because the base is the
You
same.
keep the base.
Okay.
So,
That's sure.
yeah, it all goes back to what we talked about earlier, the very beginning, where we had somewhere around here.
I remember you saying you could multiply
And that's what
these
the last
two,
part
you're
is.
thinking multiply 2 and 2 instead of keeping 2 and 2 the same.
Yeah, and that is kind of a mistake people make. They're going to put a 4 there. People will put a 4. They're going to say that's 4 to the 7th.
Yeah.
And you know that can't be because 4 to the 7 does not even equal this.
So you only multiply when they're different, like on number 30, when we had like the negative 7-8 and the 7-8, you only multiply when they're different.
Number 30. Now, what do you mean you only multiply when they're different?
Like we have negative 7-8 and we have 7-8.
Okay?
That's 2 different equations.
No, that's 2 different expressions. This is negative 7a cubed, b cubed. This is 7a to the 19th, b.
Okay.
So remember the process we said, all this is multiplication. So what's a negative multiplication? The multiplication is commutative. The order in which you multiply does not matter. 5 times 6, same as, 5 times 6, same as 6 times 5. So I can say negative 7, even though 7's here, I can say negative 7 times 7 is negative 49. Then we know about the product rule. So if I cover all this other stuff up, what's a cubed times a to the 19th? A to the 22nd. Then if I cover all this other stuff and only have what's left, what's b cubed times b? B to the 4th. Okay? So the base is, I'm not sure where you're coming at with your question.
I think I kind of
Yes.
understand. I think they're asking, like, you see how we got the 2 and the, we kept the 2 and the 2 the same on the right hand side? Well, up there you have a negative and a positive number.
What are you talking about
Like
up there?
On number 30. That's what but there are 2 different properties that we were working on. I think is what they were getting confused.
No, the same property. It's a product rule. There's only one property we used here. I'm not sure what you're talking about. A negative 7 times a positive 7, you're just multiplying 2 numbers together. Those are coefficients. Remember when we did this, I said deal with the coefficients first. What's a negative 7 times a positive 7? It's a negative 49. I didn't use the product rule there. I just used the fact that a negative 7 times a positive 7 is a what? Negative 49. Now I'm using the product rule with the a's and the b's. Because a to the 3rd times a to the 19th by the product rule means I add the exponents. 19 plus 3 is 22. Now, if you remember, the long way would be a cubed means a times a times a, right? A to the 19th means a times a how many times? Altogether, how many a's do I have? 22. Now, the b's. This is b times b times b, and this is b. Altogether, how many factors of b do I have? 4. All right? So here, going back here, when I divide like bases, I keep the base, and what's the base? 2, and I do what to those exponents? Subtract them. And it's always the top exponent minus the bottom exponent. So what's 4 minus 3? 1. Okay? So remember, this is called the product rule. This will be called the quotient rule. So this is rule number 5, quotient rule. So the quotient rule says this. When you have a to the m power divided by a to the n power, a to the m power divided by a to the n power. I'm dividing like bases. So when you divide like bases, you're going to end up doing what to those exponents? Subtract those exponents. So what you do, though, is you rewrite the base. What's the base? A. And then you're going to say the top exponent, which is what? M. Subtract the bottom exponent, which is n. That's what the quotient rule says. Over here, if you were to do this, it would be, you add the exponents, it would be a raised to the m plus n. Here it's a raised to the what? M minus n. So product, you add the exponents, quotient, you subtract. And we did this to kind of show you why you subtract. This was the example to show you why it's a subtraction. All right, so let's look at this now. This is going to be 56. So some of these you can just do in your head real quick. This one that we're about to do, you can do in your head real quick. Y to the 10th divided by y to the 9th. That's a 9. What's the answer? Y to the first, but we just listed as what? Y. That's the answer. Y. You subtract exponents, right? 10 minus 9 is what? 1. All right. Now 58. So in my math lab, remember a while ago when we did this problem? Let me find it. It was the one with the -5. I have pages all over the place now. We had done one with the -5 in it. Oh, here we go. It was number 24. Remember we did number 24? We were multiplying these two expressions. The bases were the same. So the answer would be the base raised to the power. So -5 raised to, and then what to those exponents? You added the exponents, you got 13. And we left it like that, right? Yeah. Okay. In a 58, though, it says this. It said -6 raised to the 13th divided by -6 raised to the 36. All right. Now, what are you doing to those bases? You're subtracting. Well, I'm sorry. You're dividing them, right? The numerator and denominator. You're dividing like bases, correct? All right. So since I'm dividing like bases, what rule am I using? What's that rule called? Quotient rule. And the quotient rule says I do what to those exponents? I subtract them. I subtract those exponents. So you're going to rewrite the base, and what's the base? -6 in parentheses raised to what power? Oh, I'm so sorry. That's not 36. No. I messed up. That's not 36. That's 11. Sorry. Now, notice she said negative. Remember, she said negative, right? That's the next section. It's going to be 2. So that's -6 to what power? To the second. Okay, now I want to go back and find the one with -5. That was number 20. If I can find it. I can just lose things real quick. Number 20. And I just had it.
You said the 5?
Yeah, it was the one with -5 that I just showed you. -5.
It was number 24.
Oh, 24. Okay. All right. So here, remember right here, we left it as negative 5 to the 13th.
Yeah.
Remember, they're assuming you don't have x as a calculator here. Well, there's no way they would expect you to figure out what negative 5 to the 13th is by hand, right?
Right.
Because that means negative 5 times itself how many times? 13. Well, they're assuming you don't have x as a calculator, so you'd leave it like that. But here, they expect you to figure out what negative 6 to the second power is. What is it? 36. So in my math lab, you would have to not leave it as negative 6 squared. You would have to actually indicate that it's 36. Because that you can actually do. Negative 6 times negative 6 is what? 36. Negative 5 to the 13th power, you can't really do very easily by hand. That's negative 5 times negative 5 times negative 5. I mean, that's going to be a huge number. All right, so that's 58. Now let's look at this one. So here's how you get number 60. So listen carefully to number 60. Listen carefully. All right, number 60, you have x to the 8th, y to the 6th, divided by x, y to the 5th. Don't make it difficult. Listen to what I'm about to tell you.
You want to still subtract, right?
Yes, but listen carefully. All right. So kind of remember something you've had in the past. If I have, let's say, let's say 2/3 times 4/5. Okay? So notice I'm multiplying these two fractions, correct? Couldn't I rewrite this as just one fraction instead of writing it as a product of two fractions? In other words, is what I'm about to do the same thing? Multiply the numerators together, 2 times 4, and multiply the what? Denominators together. So I went from a product of two fractions to just what? One fraction. So here I want you to think about it going the opposite direction. So I want to go from one fraction to a product of two fractions. And you can skip this step, but that's the process we're going to go through. So in other words, do y'all agree I can write this as x to the 8th divided by x times y to the 6th divided by y to the 5th? Yes or no?
Yeah.
Yes. And so by writing it like that, you can now see that if I cover this part up, I'm using what rule here? Quotient rule. If I cover this up, I'm using what? Quotient rule. But you didn't have to write like this. You could have just gone out here and say, all right, I'm dividing the x's and I'm dividing y's. So I'm dividing like bases. What are those exponents? I do what to those exponents? Subtract. So 8 subtract what? 1. And so what's the answer? X to the 7th. And now the y's. That's y to what power? Y to the first is just y. So the answer is x to the 7th y. But you don't have to do that middle step. Just notice I just wrote it there to kind of show you that you are dividing like bases. You are using the quotient rule. Even though you have different variables involved, you're still using the quotient rule. So use the quotient rule with the variables, x, and use the quotient rule with the y's. All right, and then let's look at 62. Now, the way you're going to do 62 is this way. All right, so 62, you have 9. Oops, okay, let me finish this and then we're done. 9, a to the 4th, b to the 7th, divided by 27, a, b squared. All right, now, here's the way you're going to do this. Real quickly, the difference between 62 and 60, look at the coefficients. 60, what was the coefficient in the numerator? 1. What was the coefficient in the denominator? 1. In 62, it's not 1 anymore. So what I would do is this. Now listen carefully. Circle the coefficients. And then kind of deal with it last. Circle the coefficient, deal with it last. So I'm going to cover this up. If the coefficients were 1, what would your answer be? A to the 3rd, b to the 5th, right? Okay, that will be the answer if this right here will be the answer if that's all you had. But that's not what I had. So now I'm going to cover this up because what I had was 9 over what? 27. Last semester, How did you reduce 9 over 27? What's that? 1/3. 1/3. So now what you're going to write the answer as is this. This is going to be your answer. 1/3 and then this.
Yeah.
A to the third, B to the fifth. Okay? The other way, guys, the other answer that you can write it as is this. And I want you to understand this is true. You can write it as A to the third, B to the fifth, divided by what? No, not 1/3. 3. 3. Because that's all this divided by this. Okay? But most students don't write it like this. Although you need to understand this coming up. We're about to look at this in a section or so. But for right now, just write it as 1/3, A to the third, B to the fifth. So we're going to do one more like this next class period, and then we'll be done with this section. Now, a while ago, I messed up with the exponents, and so someone said, well, it's going to be a negative exponent. That's the next section. So the next section is going to deal with negative exponents. But before you can do negative exponents, you have to be able to do this. Okay? All right, real quick, I know I'm running out of time, or ran out of time. Okay, so I don't have the keys to the worksheet. Remember I left the notes, and I also left the key to the worksheet that's due. So if you want to turn the worksheet today, you can, or you can wait until next class period. A and B. Okay. Remember I sent you an email about that though, right? Okay. So A and B. But I think you turned yours in already. Yeah. So if you can turn it now or turn it next class period, I don't have the key to it. But let me kind of get you started on some worksheets for what we're talking about. So I'm gonna put up some worksheets on that table. And I didn't take the roll.
We got one.
Oh, okay. All right. Because there are quite a few people absent, so I need the roll. Okay, I need for you to work on the product rule. This is the product rule, and this is the thing that we did last class period. So start working on those. If you want to start working on the quotient, on the power of a product, you can as well. But here's what, just pick those up, and I'll tell you what to do Tuesday, this coming Thursday. Pick those up. So the key thing that you pick up. And if you weren't here last class, you need to pick up your test. Kiara, Rowan's still not here. Okay, Joan, you have some old stuff in here.
Here.
Oh. And here's the key. Joan, you have something in here. Maisha, this is old stuff. Make sure there's nothing else. Joan. Katie, she left. Joan, this is. Thank you.